NASA is about to face its ultimate test of life and death. A slight re-entry angle shift or abnormal heat shield ablation. Communication blackout, parachute deployment, and G-force endurance. If any single item fails, it could cause the entire mission to fail. Tomorrow morning at 7:30, Artemis 2 will experience these dangerous dozen minutes. Because the Orion spacecraft returning from the moon is about to, at a speed close to 38,400 kilometers per hour, slam into Earth's atmosphere. At that moment, the outside air will be compressed to the limit, rapidly heating up and ionizing, turning into a high-temperature plasma layer that almost fully envelopes the capsule. The astronauts will see a glowing white expanse outside the windows. The spacecraft body will shake violently, and the G-forces will grow heavier. Worse still, starting from this moment, comms will suddenly cut off and the ground will not hear it. The screens at the Mission Control Center will also fall silent for a short time. This is the blackout moment that all return vehicles must face. But precisely because it is a blackout, that these few minutes are the most terrifying. If the heat shield holds up, the signal will come back. If it can't hold up, there's nothing the ground can do. This mission is already nearly complete. The 4 astronauts have already orbited the moon, and NASA has once again proven that it still has the capability to send humans back into deep space. But in the end, what truly decides the success of this mission has never been flying out, but whether they can be brought back alive. Going to the moon is primarily a matter of propulsion. Returning to Earth is a matter of survival. So today, we are focusing on only one thing. Where exactly lies the difficulty of tomorrow's event? You should know that a lunar return and a space station return are simply not on the same level. A space station re-entry enters at about 28,000 kilometers per hour. This is already very fast, but at this speed level, humanity has ample experience. However, as Orion returns this time, it is close to 38,400 kilometers per hour. At this speed, the air ahead has no time to get out of the way. Instead, it will be directly compressed, heated, and ionized, turning into a layer of high-temperature plasma. The temperature on the surface of the heat shield can approach 2,760 degrees Celsius. What does this mean? Ordinary structural steel cannot withstand this temperature at all. Many metal structures would quickly fail without sufficiently reliable thermal protection. The outer hull of the Orion spacecraft would barely last a few seconds. In the end, what stands between the crew and extreme heat is not romance or courage. Instead, it is a layer that must ablate as expected, peel off as expected, and work as expected. This layer of material is called AFCOAT, a carbonizing ablative thermal insulation material. Protects it not by being indestructible, but by actively sacrificing itself. During re-entry, it will carbonize and ablate layer by layer under extreme high temperatures, carrying the heat away bit by bit, so that the capsule can survive. NASA used the same approach back in the Apollo era, so the Orion spacecraft continued along this line. However, the Orion spacecraft and Apollo are not exactly the same. The heat shield of Apollo back then was composed of a vast number of small honeycomb cells, which were filled one by one. The large heat shield of Orion, however, was changed to be assembled from 186 prefabricated blocks of AFCOAT material. The overall diameter is about 5 meters. This means it is no longer a single piece of uniform material, but a complex system that must work together as a whole under extreme environments. The thickness and ablation method of every single block, specifically AFCOAT, affect execution. And this is precisely what the outside world cares about the most. Because after Artemis have returned, engineers found upon inspection that this heat shield did not work completely in a way originally predicted. That uncrewed test flight was successful, but once it was disassembled after recovery, engineers found that the carbon layer of the heat shield showed abnormal cracking and peeling. It was not that uniform, predictable surface ablation. Instead, irregular chunks directly fell off in some areas. Later, NASA spent a long time investigating. Confirming the cause was that during re-entry, gas generated inside the insulation did not vent out smoothly as expected. As a result, internal pressure built up, ultimately cracked and shattered the surface carbon layer from within. The problem is not just that material fell off. What is more troubling is that this indicates its ablation behavior is not completely identical to predictions. And for an ablative heat shield, the ultimate fear is, you know it will burn, but you do not know how it will burn. NASA later confirmed that, although abnormal char layer shedding occurred during Artemis I, if humans had been inside at the time, according to the flight data, the crew themselves would have still been safe, and internal temperatures remained safe throughout. This is very important. It shows it is not no big deal, but rather another more realistic matter. Just because it can save people does not mean it has no issues. And since it failed, does not mean you can confidently act as if nothing happened next time. More critically, this problem is also related to the re-entry method itself. Artemis I utilized a skip re-entry, meaning skipping into the atmosphere to slow down, then using lift to briefly bounce up, followed by a second dive. The advantage of this method is that it offers flexibility for recovery, but the downside stems from this as well. After the first heat phase, when the craft bounces up, heating weakens, the outgassing capacity of the char layer drops, and the internal gas becomes more easily trapped instead. By the second re-entry, internal pressure pushes up, and the outer layer could break off entirely. Therefore, for this Artemis II mission, NASA did not continue to copy that plan, but changed to a more direct re-entry path instead. Simply put, they would rather it be harder, and a bit faster, than giving the internal gas another chance to accumulate out of control. So, what NASA ultimately did was not simply changing phrases to gloss it over. They investigated long and performed extensive testing. NASA did not completely scrap and redo the heat shield for Artemis II. Instead, their official conclusion was, after finishing root cause checks and testing, and adjusting re-entry operations, the existing Artemis II heat shield can safely fly with the crew. This is also why tomorrow's return is actually not just a simple splashdown. It is also a real comeback test of NASA's claim we get it, and have already suppressed the risk to an acceptable range. A true real-world exam. Now, if we lay out the timeline, you will see why tomorrow is so tense. According to NASA's latest schedule, tomorrow around 7:33, the Orion spacecraft will first complete the service module separation. Note that after this step, the hardware handling power and water, and propulsion all along the way will be discarded. The only part bringing the 4 people back is the crew module. Then, at around 7:37, the spacecraft will make one final trajectory correction. From this point on, it officially heads into Earth's atmosphere. After that, at around 7:53, it will reach the entry interface, entering a comms blackout lasting 6 minutes. In other words, at that moment, it will face extreme heat outside, high G-forces inside, and ground teams will not hear it. During these minutes, the craft must rely solely on its shield, attitude control, and pre-programmed routines to tough it out. If it successfully survives up to this point, next will be the final sequence of actions. Once blackout ends, the spacecraft will jettison the forward cover. Around 8:03 a.m., the drogue parachutes will deploy. Around 8:04 a.m., the 3 main parachutes will deploy. The goal is to slash down around 8:07 a.m., off the coast of San Diego. Subsequently, recovery helicopters will transport the astronauts to the USS John P. Murtha, to undergo post-landing medical evaluations. This means tomorrow is not just about making it back, but the sequence of separation, correction, re-entry, blackout, parachute deployment, splashdown, and recovery must all go perfectly through the process for the mission to be complete. And this is not some ordinary low Earth orbit flight. This is a crewed deep space spacecraft, carrying 4 astronauts, returning from the Moon. Artemis 2 itself is a test flight meant to pave the way for subsequent missions. In short, whether future crewed lunar landing missions like Artemis 3 will move forward or not, depends heavily on whether this homecoming can be executed cleanly and flawlessly. Therefore, tomorrow morning, what NASA is facing is not just the final procedure, but the toughest exam of the entire mission. All the beautiful visuals from before, history and live stream excitement, no longer matter at this point. Only one thing matters. This heat shield, which faced controversy. This re-entry plan, which has been adjusted. This spacecraft, sending humans to deep space again for the first time in over 50 years. Can it bring 4 people safely back to the ocean? Having faced so many hazards, do you think NASA can inherit the glory of the Apollo era tomorrow and bring back the astronauts safely? I am Lama. See you next time.